God, it's Sting!
What happens when an AI model jumps from handling 1 lakh tokens to over 10 lakh tokens in a single go? That is exactly the leap DeepSeek is making with its next big release, internally called Model 1 and widely known as DeepSeek V4. This is not a small upgrade. This is a full shift in how the model thinks, remembers, and handles large tasks. Before jumping into DeepSeek V4, it helps to understand where DeepSeek started and how it reached this point. DeepSeek already runs several powerful models under the V3 and R1 families, and these models are known for being extremely large yet very efficient. Most of them use a smart design called MOE, or Mixture of Experts, where only the required parts of the model activate instead of the whole system running every time. This approach keeps performance high while keeping costs low. The V3 series is widely known for general tasks and strong coding ability, while the R1 series focuses heavily on logic and mathematical reasoning. V3.2 further improved efficiency, tool usage, and stability. Even with these strengths, two clear gaps remained: truly long memory and stable scaling at even larger sizes. That gap is exactly where Model 1/V4 steps in. What is Model 1/V4 exactly? Model 1 is not a small update like V3.2, but a separate model built in parallel with a completely new internal structure, as seen in early 2026 code updates. It is expected to launch in mid-February 2026, around the Lunar New Year, a time DeepSeek often uses for high-impact releases. With a focus on new memory design, efficient scaling, and large-scale coding, V4 is about changing the core of how the model works, not making small tweaks. Memory has always been a weak spot for large language models, and DeepSeek V4 directly targets this issue. Many models struggle to remember earlier parts of long conversations, documents, or code files. As prompts get longer, performance often drops, even in expensive closed models. DeepSeek V4 introduces a smarter memory approach designed specifically for long inputs. At the center of this change is a redesigned KV cache, which is how the model remembers what it has already processed. Model 1 uses a new cache layout that handles extremely long inputs without slowing down. This becomes crucial for large codebases, long documents, and multi-file projects. Problems like repeated answers or losing track midway are expected to reduce significantly. This change alone makes V4 far more reliable for serious, long-form work. One of the most important upgrades in DeepSeek V4 is Engram memory, inspired by how the human brain remembers repeated patterns. Instead of recalculating the same phrases or code again and again, Engram stores them once and recalls them instantly, leading to faster responses, lower compute waste, and stronger reasoning. Internal tests showed long context accuracy close to 97%, with clear improvements in math and coding, even on very large projects. Alongside this, DeepSeek introduces MHC, Manifold Constrained Hyperconnections, a system that lets the model grow past 700 billion parameters without becoming unstable or expensive. Together, Engram and MHC turn long memory and large-scale training from a weakness into a real strength. DeepSeek V4 is clearly designed with developers in mind. Internal evaluations suggest major improvements in coding performance, especially for complex, real-world projects. The model is expected to understand logic across multiple files, keeping track of how different parts connect without losing context. Even with very long code inputs, the model remains stable and avoids repeating errors. During refactoring, code structure is preserved, which is critical for safe updates and maintenance. V4 also shows promise in repository-level bug fixing, where it understands the root cause instead of endlessly fixing surface-level issues. Many current models fail here and fall into loops. DeepSeek V4 aims to move beyond that limitation. This kind of reliability is exactly what developers have been waiting for. Early reports suggest DeepSeek V4 will push the limits of scale and capability. The total model size is expected to cross 700 billion parameters, with around 40 billion active parameters per task, thanks to the MoE setup. The most dramatic jump comes in context length, moving from 128,000 tokens to over 1 million tokens. The architecture combines MoE, Engram memory, and MHC, backed by improved reinforcement learning methods. This change completely transforms how AI can be used. Entire books, full software repositories, and long legal documents can be processed in one go. This is not just a spec upgrade, but a shift in how AI handles information at scale.
DeepSeek is expected to launch V4 in 2 variants, each serving a different audience. The V4 flagship version is built for heavy workloads, large coding projects, enterprise use, and deep reasoning tasks with very long prompts. It focuses on maximum capability and depth. On the other hand, V4 Lite is designed to be faster and more cost-efficient for daily use. It handles general tasks smoothly while requiring less hardware. This dual strategy allows DeepSeek to compete both at the high end and in cost-sensitive markets. It also gives users flexibility based on their needs. From both a technical and business perspective, this is a very smart move. DeepSeek follows a clear pattern when it comes to major launches. Big releases often happen around the Lunar New Year, a time when global attention is high. The earlier R1 release during this period caused strong reactions across tech markets, which is rare for open-source AI. Launching V4 in February 2026 follows the same strategy. This timing also matches a growing demand for self-hosted AI, especially from companies concerned about rising API costs and data privacy. By releasing V4 at this moment, DeepSeek positions itself right where interest and need intersect. Timing here is not accidental, it is strategic. If DeepSeek V4 performs as promised, the impact on the AI landscape could be massive. Open-source models matching or beating closed models changes how companies and developers make decisions. Engineers gain full control, avoid API lock-in, and benefit from better long-context tools at lower cost. Companies benefit from reduced long-term expenses, stronger data privacy, and protection from sudden pricing changes. Custom tuning also becomes easier. All of this makes a strong case for adoption. However, real-world performance still needs validation. Promises alone are not enough, and benchmarks will decide everything. Performance claims mean little without proper testing. DeepSeek V4 must prove itself on key benchmarks. On SWE Bench Verified, it needs to cross a 50% success rate to outperform top coding models. For long context tasks, tests like Ruler and NIAH must show memory accuracy above 95%. Inference costs should be lower than V3 while delivering better quality. Most importantly, the model must be released under a true open-source license with full access to weights. Once these results are public, the real picture will emerge. Until then, excitement remains high, but expectations stay cautious. DeepSeek V4 is more than just another AI release. It signals a shift in how open-source AI is designed and scaled. With smarter memory, efficient growth, and a developer-first approach, it challenges the idea that only closed models can lead. If V4 delivers on its goals, it could set a new baseline for the industry. Closed models would then need more than branding to justify their price. The next few months will be critical. And the final question remains simple. If open-source AI can handle million-token prompts and massive codebases at lower cost, what reason is left to stay locked in? If you enjoyed this video, don't forget to like, share, and subscribe to our channel.